How's it going, everyone? Julier Gonzalez here again, and today we're gonna take a look now at the front-end system design, which is part of this series of videos from my particular perspective, and because this is the service that I want to provide to clients. That is, well, I'm going to be now a UI specialist, and if you're going to now provide this user experience and UI and UX, all right, to several companies for the admin dashboard, or even like this kind of interface right now that you're looking from the Google Docs, anytime you're going to build is any of this particularly user interface, we need, and I say we because if you also wants to know more about this and wants to dedicate time to actually provide this as a service, so UI as a service, all right, or if you need to build something for yourself to fit your own needs, that's also something important too. So the TLDR of this is we need to learn is the fundamentals of system design, and especially if you want to build now more complex web app. So the reason of this course is which is targeted or oriented to UI specialists that want to know more about the fundamentals and how all of these different building blocks fits together as a way to now solve or provide some of these UI large scale web apps, right? So again, because the entire goal of this is for not only an economic purpose or an economic output, which is one of the reasons why I'm actually doing this, but also if you need to build something for yourself, something that you need to, right? So because of that, this course is laid out in this particular way: introduction, core fundamentals on API, web API virtualization, application state, web application performance, system design, interview. So each one of them, right, is just a story that we need to understand as a way to move on to the next one. It's pretty much like you're reading a book, and as you read more about this, you're starting to understand more and more and more, right? So it becomes quite more interesting. But unlike a book, which it can talk about is a novel or a sci-fi or something based on real events, right? Unlike that, we can now in this particular case get something. So we got a more practical approach to this, so we can actually do something. We get something out of this. In this case, building UI. So in today's video, all right, we're gonna focus on the DOM API, okay, as a way to now lay out the foundations and understanding now all of these different components, how that works, and especially when you need to create your own, how all of this fits together. And you are wondering is that how all of this narrative, how all of this story makes sense when it comes to build a web application. So we're gonna make a quick recap of the core fundamentals and then jump in straight forward to the DOM APIs. So because this course is primarily for UI specialists, that if you're building an application, it is made of 3 layers: the backend, the API, and the frontend. In this course, we focus our attention is on the frontend, and inside of here we get is, according to Yvonne Ray, which is the instructor that has previously worked at JetBrains over 3 years, and now he's currently working at Meta, where the idea of understanding these fundamentals, or what is a front-end system design, or what are the anatomy of an application, okay, and that is the backend, the API, and the frontend, and how now the frontend has several components which is part of the front-end system design. So you got is now how you're going to communicate with the API, how you're going to manage the UI once you fetch that data from the server, how you're going to store it, how you're going to manage, and then how you're going to create now particularly UI patterns as a way to now provide and cover some basic use case. Now how you're going to is manage all of the assets that you are downloading from the server in a way that you can provide is a quick feedback to the user and improve the user experience. So as I mentioned, the course is organized in this because the main focus on today's video is the DOM API. Let's get and take a look at a quick recap of the core fundamental, which is if you're gonna build your user interface, you're gonna build this web applications on the front end, you need to know is now how the browser treats, which is the way of how you go. This is the platform that you're gonna build all of your you're gonna build your application, okay? And from there is like, all right, so now we got this. So now that we got all of this, now that we got is the browser, okay? We need to understand now how the browser actually treat each one of those HTML elements, right? Because at the end of the day, the end goal is to build all of this UI. All right, I'm quite redundant, I know, but the idea here is to actually to always pretty much like in a compass, okay? You get now the north, always pointing to the north. That's the reason why I'm repeating. So, because the browser now treat all of these elements as blocks, so when you want to provide some style to those HTML elements via CSS, it treat that as a box. So everything in CSS has a box around it, and understanding how that works and how that interact with other elements can allow you to build now more complex user interface. So as we look at now the box anatomy, which is the content, the padding, the border, and the margin, followed by the type of box or the box properties, okay, whether it's by its size and by its type. So the box size here is determined by its intrinsic value, whether it's the content, the width and the height. It is determined by it as a content, or it can be restricted because you can apply some CSS rules to this particularly HTML elements, all right, and then you can change the size of that box. So by putting some rules like width and height, or perhaps the padding actually control is the width and height, the percentage of the padding component, the padding container. Aspect ratio is another property as well. And if that element has now siblings, all right, at that position, it also is the types of boxes, whether it is block, inline, and anonymous. We're not gonna talk about anonymous, but anonymous exists, and this is just the way of now how you can is because the browser, if you don't put any particularly HTML tag around, if you don't use a particularly HTML tag with content, or if you don't put a content in, if you don't put a content, or if you don't wrap some context into a particular HTML tag, the browser actually automatically wrap that content into a box, anonymous box. So we have now the blocks and the inline. So now each one of them actually now provides certain rules of that. So for example, in the block is going to render all of these elements from top to bottom. And the width of this box, it'll be 100% of the padding container block. and it participates in something called the block formatting context. And I'm gonna stick with this concept, block formatting context. The other is the inline type of box, where now here there's certain rules that applies to certain HTML elements. So for example, you can modify as or width and height doesn't work here, as well as vertical align, and items are rendering like an string, so next to the next one another, is in a sequence next to each other, and they participate in something called like the inline formatting context. Why this is important, this formatting context? Because the key feature of that is that the browser can now isolate those type of boxes or any of its children's boxes inside of that, to not only make it scalable when it comes to define which type of which type of formatting you want to provide to this block and all of its children's. So for example, you can say is well, I want to this be flex or grid type block or inline, which means that it's make it scalable, because you can not only is for the layout designers, they can create another type of layouts, right? And then you can easily use that by using it as a display and providing is the particularly formatting context or the layout context, right? Or the layout design, right? Which make it predictable, because now you know how all of these elements are going to behave. So the reason of looking at the block formatting context, inline formatting context, the key aspect of the formatting context, and followed by the positioning of the browser, and how the browser actually put all of these elements. So it follows something called the normal flow, where it's going to put all of these elements from left to right and top to bottom in a way that actually follow that normal flow. If you, for example, wants to alter the way of how the browser position elements, you can do that using a CSS class or CSS property called a CSS property called a CSS property called position. My bad. So with positions, you can tell the browser, hey, I want you to now is all of these elements inside of this formatting context, I want you to now put it into a different flow, or put it outside of the normal flow, meaning creating a new stacking context. So for example, position relative actually do that, because by default you have all of these elements position static, all right, and the position relative actually follows some particular rules, right? That is, you are telling now the browser to treat these elements and take all the available space needed, but it's going to modify the position of these elements here, only that on these elements, and it's not going to impact on other elements down there. So effectively creating is a new stacking context, all right? There is something called as a container block, where this is something it is used when you tell now the browser to actually use that container block for putting now in a stacking context relative to that, by actually telling, hey, the position absolute it is. So position absolute is now going to look at the closest position relative, because it's going to use that as the anchor, because this is the way of how you can tell the browser, hey, I want you to now create this another stacking context But now I want you to make it relative to this, or to this containing block. If the container block, if the position actually couldn't find anything, couldn't find any of its ancestors as position relative, then it's going to look at the initial containing block, which is the HTML. So knowing this, and especially when you're using position absolute, no space are provided to these elements, and then you can use this top, right, bottom, left to move the elements as you need to, right? Why this is important, you may wonder. Because when you're using, for example, position relative, absolute, CSS transformations, or any other element that, or any other CSS property that actually change the normal flow event, which is creating a new stacking context, you can now wrap those elements inside of this stacking context and make it, and you isolate them so other elements won't affect them, one. And the other is that you can now tell the browser to do some performance optimizations, because these particular elements, when you trigger the DOM tree, is something that is quite expensive, and the idea here is to not triggering reflow. And you may wonder, what is reflow? Well, this is the process of how now the browser, this is one of the stage at the assembly line of the browser, of how the browsers now treat all of the HTML, CSS, and JavaScript elements into pixels on the screen, right? So you have now the DOM, the CSS object model that is now shipped, that, or that is merged into the render tree. And now the browser know all the informations about these elements that you provide, as well as its style. But the thing is that it doesn't know when you need to put it. That's when you have now the reflow phase, which is the processing, how the browser is now positioning all of these elements on the screen. And also that's quite interesting how that reflow works. I'm gonna leave that be because this is not relevant for the course today. But reflow flow, let me actually ask, now that we are here, you know what, slightly reflow, perplexity, bro. Reflow, oh, I wasn't aware of this. Oh, I wasn't aware of this. What? I wasn't aware of this. That's quite interesting. Reflow happens when a browser recalculates the position and geometry of certain part of the web page, such as after an update or an interactive site. This tends to be followed by repainting, which is when the browser redraws the web page to show the resulting visual updates. And then you get the repaint. Understand the reflow and repaint in the browser. Exactly. Reflow will happen when you now update the adding and removing and updating DOM nodes, hiding DOM elements with display and visibility. You're actually causing them. Interesting. Because no layout or position change. Moving and animating a DOM will trigger reflow and paint. Exactly. Moving and animating a DOM, resizing the window will trigger reflow. Changing font style alter the geometry of the elements. That means that it's affected the position. Adding or removing style sheet will cause the reflow repaint. Script manipulations, the DOM is an expensive operation because they have recalculated each time the document or part of the document modified. Minimizing, 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 reflow. Chrome tool performance. So in any case, yeah. In any case, I wasn't aware of this reflow. Anyway, I wasn't aware of reflow was a part of, okay. Performance consideration, reflow soldering in electronics. Process stop, solder, paste application, component placement, heating. But in any yes. Reflow. Reflow prior. So in any case, yeah, it triggered now reflow, okay? Which is this. And this is mainly caused when you alter the position of the geometry of those elements, right? So the browser needs to actually calculate the HTML, the DOM and the CSS object model, create the render tree, so you need to actually pass through that. So activate is the layout phase. The idea here is that we can use some CSS class as a way to, when you're creating your formatting context, therefore you can now use some of these optimizations on this layer and all of this stacking context as a way to create and to build now is application that don't block the main render, which is that doesn't trigger too much reflow. So that's why we look at, for example, transformations that actually, instead of using CPU, all right, they use is now GPU. And you may wonder how that actually works. Well, thanks to this thing called composite layers. So the browser this is the way of how now the browsers talk to the GPU. So by providing you now particularly HTML DOM structure, and then you say, all right, I'm going to apply certain rules to that. First, I create the render objects, where now you have a representation of all of these nodes and as a tree, right? But if you, for example, wants to now trigger or wants to go deeper or talk to the GPU, so if you change now the flow, if you change the normal flow of formatting context, or a block of element, or a section of element, or child elements, and I prefer to call them as a formatting context. Okay? If you change now the normal flow of a formatting context by using the position absolute, relative, also you use transform, you actually do that. HTML is also someone. It now effectively the browser is this render layout, right, for that particularly formatting context. However, sometimes you want to now make things much more performance in terms of talk directly to the GPU. That's why you have now the graphic layer, where, for example, elements like video and canvas actually use this layer, all right, and property like 3D or transform, or properties that transform, like CSS, actually make use of that layer. So all of this was just to understand now how the browser actually, when you take a look at this, let's see, it's this one. Oh, my bad. My bad. Okay.
So now?
Exactly. So, the whole point of this is to see now with an example, right? It's gonna put
This means
the
you
initial
can absolutely put it some text.
Like this, which is the root element, which is the step 1, and then
Taking context there. So we initiate it now to flex items. So next we render. When I render the body, the DOM tree is updated.
so this is now rendering as a body, then rendering as a section. Then after you render the section, then you're gonna render is this, and then after that you're gonna render is this, and after that you're gonna render is the transform as it is. So all of this snapshot that I'm taking right now here is just as a way to say finder. No. Okay, what about finder? Finder. Finder. What if I want to take a look at the finder, bro? Yeah, what about the finder, bro? Where you can open the finder, no? It must be here, that's right. With all of the downloads, but I think all of this you upload that exactly today. There you go. Alright, which is all of this, right? So we put all of this different step here. So why we did this as a way to now understand that how now the browser is starting to render all of these elements and become some sort of reflow Jedi. Why is that? Because once you know how the browser treats HTML elements and how the formatting and the stacking context are related each other, as a way to now utilize as a way to trigger reflow as much as possible by using is now as the GPU acceleration, hardware acceleration, or in other words, you're now wants to know how the browser use the GPU. Alright, it is important to actually know now, well, what are the tools that we can use that way to build this and to trigger that. So the DOM API is this set of methods that allow us to interact with the DOM. This is not exclusively to JavaScript, which is to me was initially something quite interesting. This is just as a way to say, hey, because JavaScript was built on the browser, and the browsers now, the whole point of this is to render all of these HTML documents in pixels on the screen. And as the year passes, and that becomes more and more complex, aka it provides more meaningful features. So for example, now you can tap, or that you can click on the browsers, or you can define some sort of that kind of thing. The whole point of this is, well, now yeah, the whole point of this is that yeah, is that how now are going to sorry, because remember, JavaScript was designed for the browser, and the browser now have this so the goal of the browser is to render this HTML document that we send over the cable. And as the years pass from that initial release of the HTML in the browser, where now instead of actually showing is HTML, is now you can show is CSS and JavaScript. And now how JavaScript is this scripted language, line by line, it is executed, and this is how you can now have access to the DOM, or this document object representation model. So the idea here is that you are now capable to manage, manipulate, and provide some more interesting features to these applications in a way that is that is something that you want, in a way that'll be in a way that it makes sense for using JavaScript with the DOM and that kind of thing. But you can use is the DOM with other scripted language, for example, like Python. So by importing is that building tools and then parse that HTML and then start to operate or work on that, manipulate that. This is another way of how you can do that. And I think this is something interesting because the DOM was designed not to be language specific. It was designed to be language agnostic, platform agnostic. So anyone who can access or who now implement this object-oriented model can have access to this. All right. So I think that's something quite interesting, and there is a lot of people behind the scenes that dedicate a lot of time, bro. It's like, but a lot of F time, bro. A lot of F time. Oh yeah, it is. Damn it is, yes. A lot of bad F time to do that. So because of that, the reason is that once you know about this, that the DOM is not exclusively to JavaScript, and after all, that the DOM is just this set of tools that allow you to now manipulate and interact with the DOM. All right, and most of us, we don't actually have to interact with the DOM, so we're relying on a lot of frameworks to do that. So for example, like React or Angular or Vue, Svelte, among others, to actually do all the heavy lifting for us. jQuery is another one. And they don't mention that, but they like it or not, jQuery is another one. To actually make it all of these interactions, okay? The thing is that sometimes you need to build some low-level libraries, like graphics, for example, charge engines, or video players. So you need to create these genetic components, or you also need this to work with low-level libraries, right? So for example, hey, you need to create a virtualization, or you need to create a DOM management, okay? Or perhaps you just want to simply make a lightweight, developing developing a portfolio with minimal blueprints of your apps, right? You're gonna make it as lightweight as possible. That's all. So how you can do that? You may wonder. Glad you asked. That's the reason why we are here looking is at, well, what are now the global objects that we can have access to the DOM, all right? Followed by the class hierarchy. And this class hierarchy is coming from the object model, okay, as a way to understand now what are the objects that you can interact and that allow you to manipulate, all right, to work with the HTML, with the web page. So the global objects here in JavaScript, which is the DOM API, is like, hey, you have now the window objects, you have the HTML, which is something you can have access through the document.html or through the window document, okay, as well as the document.body or window document.body and the head, right? It's important to understand what is the structure of the HTML. You have the HTML, you have this head, followed by the style, sometimes the script, and then the body. Or you can have also is now script below the body. Okay? So, things slowly but progressive started to make a lot of sense. So, now that we look at the
So what is the DOM?
and that the DOM is not exclusively to JavaScript. The DOM wasn't designed, and I love about this design, and it is all about design, problem design, and especially if you are designing software, designing systems, you're gonna see very very quickly that you want to see quickly, fairly quickly, the flaw of your design or your solutions, and then you need to come up with some solutions that will create more problems, and those problems actually you find some solutions and so on, and then you are trapped. And then you are trapped, which is something that we are here right now. We are trapped by the problems that a lot of our ancestors couldn't handle, couldn't find any solutions. But they provide us some of their tools on how they did that. So this is pretty much like the Olympics, when they're passing the torch to one generation to another. Makes sense. Makes a lot of sense. Makes a lot of sense. Makes a lot of sense. Ooh, don't tell me that shit, nigga. Oh, no. Okay. I think that's a sign. I think this is a sign.
API. So the DOM API is a set of methods that we can utilize to manipulate the DOM. And usually we don't use it directly because most of the libraries are handling the DOM mutations for us, for instance, React, Angular, or Vue. But there are cases where we actually need to use the DOM API. And one of that is when you're building some low-level library that works with virtualization or some DOM management. Also, it's used when you...
Oh, right. Of course. There is no... Lovely. Well. I'll have to move to another location to actually record this video. So it'll be all. Take care. Bye bye.